Today I'm going to talk about how we automated a cinematic pipeline for new tales from the Borderlands. So first, we're going to talk about the stakes that we had for the games. Then we're going to talk about the state of our pipeline at the time. And when I say pipeline, it's because there wasn't much of it. Then we're going to talk about what is a cinematic pipeline for our game, what tools we made in order to do the cinematics, and then what is next for that pipeline. But first, who am I? So I'm currently a senior technical animator at Gearbox Studio Québec, and I've been in the industry for over 12 years now. I come from a motion capture background and outsource. So I've had the chance to work with a lot of companies and therefore a lot of pipelines. But New Tales was the first one that I got the chance to do from the beginning to end. And it was a great opportunity to see where the team started and how we managed to get through the production, building a pipeline that could support 12 hours of cinematics. So a small side note, I wrote down important stuff on slide to help you cope with my French accent. New Tales is a narrative interactive game. It's the new installment of Tale from the Borderlands franchise, so it's the new Tale. And as the player, you influence the storyline through your decisions. Each choice you make will get you through a different path. It's very cool, but it means a lot of content. And to provide the various possibilities, we have to produce a lot. For this project, one of our principal challenge was to output 12 hours of cinematic in a very short amount of time. We had over a year and a half of production with a very, very small team. To give you a comparison, a movie is 2 hours on average, it's 2 to 3 years of production, and you have scores of people. So most of the game is animation, so it has to look good. You're just looking at animation. So we don't have a cinematic pipeline. How do we push our animators' quality standards in such a short development period? We have to make sure that you enjoy looking at what you're playing. What should our artist experience be working on such great quantities with a quality bar that we have set higher? And how can we keep away from overtime? Because it's a lot to produce in a very short amount of time. To put a system in place, we just need to look at what we have. So what does our team actually do during their workday? Most of it turned out to be logistics. Every manual step that has no added value being performed by a human being. So if we look at producers and team leads and stuff like that really quick, we've all seen those wonderful Excel sheets. They're very practical in certain circumstances, but when you have to track massive volume of content, for instance, we had more than 2,500 sequences and their assets. A sequence is a group of shots. Well, you have to track that on Excel sheets. It can be crazy really fast. Then we have to create motion lists for a year's worth of motion capture. We had 102 days of motion capture recordings, not counting roundtables and rehearsals and stuff like that. Then we had voiceover that goes with that. So we had more than 7,000 voiceover lines that you need to associate to each sequence and each character. And then we had to create digital workstation and SFX creation, voiceover recordings, and so forth. And then you have to track the reception of that data and all the status for every sequence, every line, every character. So there's clearly something that we have to do here for our friends' benefit. If we look now at our animators, and we're going to look at the challenging sequence here where we have 12 Tedious soldiers. You have to import the rigs in the Maya scene for each of these 12 soldiers, and then you have to name them appropriately. And we all know how everyone follows naming convention, right? But we're also human, and sometimes we're tired and we made accidental mistakes. In this scene, 3 of them are talking. So then you have to manually assign the other lines to the character, your soldier, that is named correctly, and you have to put it on the character track. And then you have to import the correct motion of the character onto the corresponding soldier into the correct animation track. So this can easily be time-consuming, but also really, it's not foolproof. It's really prone to error. And this scene done manually can take up to hours to make. If now we look at the Unreal side of things, we have a sequencer here. So the regroupment, the shot I talked earlier. In a sequencer, every character and prop have its own animation FBIG files for each camera cut. So you can see here you have like little cuts for each camera, and each cut is a file. So in this one, we have 2 characters, 4 props, and 14 camera cuts. For people good at math here, it's 84 animation files just for this sequence. So the tech animator or animator here would have to manually import each FBIG animation file on each track to corresponding cut to corresponding character. And I can easily tell you how crazy it can become, because I've done it. So you export the animation files from Maya, you import it in Unreal, and you do that manually. It's like, no, I'm not going to do that. And you just make mistakes easily. After that, we're going to look at what we call an episode graph, which is a custom graph that we made for our game. It's a nodal representation of our narrative scripts, where you can easily see when you make a choice, it gives you a different path. Imagine someone has to look at the script and make them manually in engine. It's easily leading to incorrect assets in each sequence, missing, not up to date, et cetera, et cetera. We're not going to do that. This is something that was easily considered. We are going to automate that. There's another thing that we have to consider here is that most of our project, if not the entirety of the project, happened during the pandemic. So how do we stay connected? How do we deploy our pipeline remotely to either our outsourcers, our current or future employees? And it brings in some own challenges that I will talk about a bit later. How do we facilitate motion capture shoots? Because we were located in Quebec and our outsourcer was located in Vancouver. And we had a select member that would go there, but because of restriction, not everyone could actually support the production as much as they would have in a non-COVID world. We had also to work outsourcers. I'm going to be a bit more about that later. And everything that I'm sure you face during those trying times. So after logistics, what comes next? Well, people can finally spend time on what they do best, their expertise, what they were actually hiring to do. And the rest is just, emails, breaks, meetings, and so on. So even though we do love our franchise, it's not enough to go insane on it. So what do we do now? To drastically reduce logistics, we want to automate every manual steps. Do we custom build an entire pipeline? Or do we do have tools, for everything that's gameplay, but how do we adjust them? Do we adjust them? Or do we use an existing structure that we can customize? Using an existing base here was the most logical choice for multiple reasons. We had a very small amount of dev time, so it was easier to go with something that was already there, and it would give support, so it gives us more time for custom jobs. And we had multiple prospects. But ultimately, ShotGrid came out the winner, and there's a reason for that. ShotGrid is to give you an idea of what is ShotGrid, it's a project management and pipeline tool that helps track, schedule, review, and collaborate, and manage digital assets. While it's mostly known for its strength as managing and tracking tool, we want to show you how we used it as a technical and content creation tool. we had previous experience with it, so it already helps with the team because they know how it works, and you can easily convince people because they know it. It's highly customizable with an open API, so since narrative games are a bit different from other games, it's easily adaptable to our needs. And for our producers' friends here, it's budget friendly. And it was really time saver on numerous levels that we're going to see right after. So now, let's talk about what is our cinematic workflow. First, we have a narrative script, which is our source material. It's been written in a tool to represent the flow of choices. After that, we are going to have a storyboard, which is an image that illustrates the purpose. It's displayed in sequences with the purpose of illustrating an animation. After that comes the layout, which is the process of taking the storyboard and create a 3D choreography of the sequence, which helps us evaluate the level art needs and prepare for the mocap shoots. And it was a very important step for us because it was the first implementation in game, and it helped us notice any issues in terms of pipelines, game flow. So here, game designer could actually play the game without anything in it and find if there was issues with the game flow. And it allowed other departments to start working, specifically level art, audio, VFX with placeholders and stuff like that. Following that, we had the motion list, which serves as a base for motion capture schedules and preparation. Now that you take storyboard layout and motion list, you can actually do the motion capture shoots, which is the process of recording an actor performance, which then is transferred into what we call the scene assemble. So we import the actor's performance into the layout. And after that, finally, the animator gets to have fun with the animation. But I'm going to show you a visual representation of that because it's always fun to see it in action. So here we have the script that has been transformed and formatted for easier read for actors instead of nodal representation. After that comes the storyboard, where you can visually see the choices from the script. It's then transferred into a layout, which is a blocking, an animation blocking of the storyboard in space, which then helps the actors position themselves inside the environment when they do the motion capture shoot. So they have the script, they know what they have to say, they have the storyboard, they know the intention, they have the layout, they know the position. Then we take the actor's performance, we put it in the scene assemble, we put it in the layout phase, in the scene assemble, and then it goes directly into the engine. Now that we have an idea of what we want to do, let's get into the crispy technical stuff. We have our source, the narrative script. From that, we exported what we called a Lua file. It's a type of text file, which we import into Unreal. From there, we generate clip nodes, and those clip nodes are sequencers that contain information such as characters, prop. We had placeholder audio lines, like the robot voices generated, and it allows the game designer to start to play the game. So if we select a sequencer, we can see we have audio lines already assigned there. If I can make an apartheid here, when we create the sequence in the narrative tool, it creates unique IDs, which is a bunch of letters and numbers to make sure this is unique. And it's very difficult to work with for communication. So in that step, we do generate nice name for each node for better communication. So instead of being 7 megastar, etc., it's going to be this is sequence 102 or something like that. When we do that step, it communicates directly with Perforce. It's a versioning software that allows developers to keep track of changes, either for project code or content file. And it also talks with Wise, which is software with a graphic interface that centralizes aspect of audio creation. And then everything is linked to our ShotGrid Papai toolkit and the ShotGrid web application. So for example, in context, this is what it does. We select a custom, we select a bunch of sequences, and we have a custom tool that generates the selected sequences and send them to ShotGrid Web and automatically creates them. So you would have information such as the name and any other entities linked to it thereafter. So if you create, update, remove, everything goes through that little UI there. And then when you go into the ShotGrid Web, you can see it's generated there for you. So you already have the assets that were in the sequences, the name, the ID, and any other information that you might need. So far, ultimately, nothing has been done by hand. The writers did the job of saying, in that sequence, here is the character, and here is what prop that they use, and here what they say. And ShotGrid and all the data is generated automatically. In parallel, we have something that is very important, which we called sequence origin volume. Level artists creates it's a square shape that they put in the level, they place in the environment, and then they export via a script that we made that's automatic, the contents of that location. And what happens is that it creates an entity in ShotGrid, which is linked to a sequence, and then Animator open Maya, and the environment is loaded at the center of the world. So the center of the shape is 0, 0 in Maya. So then they can animate, and when they export, it's going to place itself automatically in Unreal at the right location. I have worked on production where your location is at minus 9,000 in Maya, and then you try to move around, and it can quickly become crazy trying to find where in your environment is the animation. With that, it's done automatically for you. So for the layout, we did have help from outsourcers because there was a lot of them to do. And we were able to easily set them up on ShotGrid. And we were able to deploy our tool via the ShotGrid desktop application. Since we were remote and most people were using their computers to work, we had to develop a tool to analyze their user environment. Since all the workstations were different, they all had an environment that were different. And most of the time, they were missing either the right version of Python or tools add-ons that we needed for the tools. So creating something that analyzed the environment and were automatically saying, yes, this is what you're missing, this is what you should install. It was very, very valuable for the remote implementations. But the layout was also our first pass in exporting everything in engine with ShotGrid Publish, which is the action of exporting the state of Maya in engine. And we could make sure the tools were working. So exporting an FBX file, importing U assets in Unreal, assembling the sequencer, placing the VO according to Maya. So that served as a functional gate and making sure that the mocap shoots were efficient afterwards. Once the sequence have been created, the layout and the sequence origin volume is there, we have all the information that we need to go and do the motion list for the motion capture shoots. So we used here a tool that's called Action Menu Items, and we export a base. So we select the sequence that we want to shoot, and then we export them in an Excel sheet for the outsourcers, and all the information is already there. This is not magic. It still requires a human to just look at the schedule, the actors, but they at least have a base that's already given to them. I want to talk also quickly about a tool that we use that was very important for cinematics that we call the camera switcher. It's a custom camera cut tool that we use that reference all the cameras in the Maya scene are referenced on one camera rig in a single bone. So it's very, very cool to quickly change frame range and to export, because you only manage one camera. You don't one bone. You don't manage 1,000 of them, depending on how much cuts you have in your sequence. And you can visualize the camera cut in the viewport. So what you see in the viewport, it's actually what's going to be in engine. The action menu items were a huge hit for animators because they were quite useful for batching stuff. So one important thing that we had was DDC time can be quite lengthy. So we used the import motion capture data via the action menu item to remove that time. It was also very useful because it automatically retargeted the source from the motion capture, so the FBX files, onto our Maya rig, and it would automatically retarget to the correct character. So if we go back to our TDR scenes from before, where you have 12 characters, then everything is automatically on the correct character. The time that it would have taken the animator, which is about a day, is now reduced to 30 minutes. That step would also generate facial files. Because of the quantity that we had, we decided to go with generated facial animation using SGX, which take an audio line and audio text, and based off of that, generate facial animation, and then how animators would then go in and fix what they needed to fix. And the other thing that was really nice is that you could do a bunch of them at the same time. So instead of opening your Maya, doing your export, and then you open another Maya scene, you do another export, you just don't go through Maya, you select a bunch of sequence in ShotGrid Web, and you batch it. So I'm going to show you now how it works in action. So sorry for the blurred stuff. It's blurred for a reason, because there's sensitive information. But here I'm going to simply open the episode graph in Unreal. I'm going to open the location of the sequence. Now that we're waiting for it to load, we're going to open the ShotGrid UI. That's the file opened with which we open the sequence that we need. So here you have all the list of the sequence on the side, and you simply choose the one you want to work on. Here we have some warning because towards the end of the production, if a shot was approved and someone was opening it, we wanted to make sure right in their face, are you sure you want to work on that? It's approved. So we made fail gates there. Once it's loading, I'm just going to go back in Engine and open the sequence that we're going to work on. And here I want to show you what's automatic about the pipeline. So we're going to get rid of Fran just for a while there, and to show you how we can automatically add tracks with characters and their corresponding animation into a sequence. And we are going to also change some camera range. So here we have the UI, the scene breakdown, which is a very important tool because it tells you what's in the scene and is it up to date, is it missing, is it there whilst it shouldn't be, and it's also going to do something that's really nice. It's going to talk to Perforce and automatically check out the files for you. So on top of that, it creates the change lists with a standard naming convention, so all the change lists are standardized, and you don't have like someone that forgets to make either a description or a description that doesn't mean anything. All the files are checked out properly. The scene breakdown is OK. You just close it. Here we see in our Maya scene, we do have Fran, even though she's not in Unreal anymore. We're going to quickly change camera frame range. It's just as simple as looking at the camera switcher, moving, dragging ends and beginnings around. Once the shot that you've modified is to your liking, we're going to open the ShotGrid publisher. Is it? OK, cool. Here you can choose either to publish a review directly on ShotGrid and in other actions, but here we're just going to look at the publish. So in green, you can see it detects that Fran is in the Maya scene, but not in the sequencer, so it's going to add it automatically. Everything that's in blue detects that you have a modification because we changed a camera range, so all the other animation has to be changed because we have an animation FBX file per cut. And if it were to be in red, it would say, oh, it's not supposed to be there, we're going to remove it. So now we go back to the sequence in Unreal, sorry. We can see that Fran is added back there. All the FBX files have been updated, and the camera cut is updated as well. So when you have to make quick change after a lead review, it doesn't take you forever to do that change. It takes you really quick, and then you can do an in-engine review, send it back directly to ShotGrid, and then the lead can verify your change. And which leads me to the automatic task status dependency, which is not very cool because what happens when you publish something or a lead manually change something that has been approved, you don't have to think about the dependency of that task. So here we can see that real time, when a task status is changed, its dependency is automatically updated. So this in-assemble is now visible onto the assigned artist dashboard. So let's say you finished the animation import by just batching it. It sends to the next one, oh, you can stop this task because the previous one is now done. So here you have the graphic representation, very simplified overview of our pipeline. For the more techie people here, I described a bit more in detail what the graph we just saw does. So if you want to take pictures, that's the moment. Or after, if you want to take screenshots. And then it's not just that, it's the second slide. I'm going to wait for you. That's the rest of the pipeline. Cool. So we've seen the pipeline we had before, and we have now the pipeline after. We were able to cut in half pretty much the logistics and to have that portion back to the animators. So they had 50% more time to work on their animation, and when you have 12 hours of cinematics, you want them to spend time on what's worth. So that's nice, but there's always room for improvement, right? And a lot of things were refined along the way because we were working on that pipeline at the same time that we were doing the game. We first improved, well, all of the above. We had better motion capture management. We have Unreal instance that opened when you publish, because before, if you didn't have an Unreal instance open, the publish wouldn't work, and if you forget to open it, or if it was closed because of a reboot, it would make some animators sad. And, sorry. Oop. We also had a Jira button for validation issues. ShotGrid action mini buttons were upgraded and extra. But that's not enough. We always want to do better. So we had a huge postmortem of what we could have had that would be awesome. Specifically implementing the Jira bridge. So we're working on that. The use of USD as well could really speed up loading processes. Have a two-way pipeline for cameras. So right now, the master is Maya, so you modify a camera in Maya, you send it in engine. But let's say you're at the end of the production and you want to change something in engine and you don't want to override that. When you go back to re-export, you want to be able to say, okay, the change that I made in Unreal, I want it to be in Maya. We want to support multiple projects that have specific needs. Tool change logs, Maya crash report that would generate Jira automatically, that would prevent people forgetting about it, speed up loading processes, and so forth. Since I'm geek, I love stats, so here's for my nerds some statistics about the pipeline. We did create an entire new cinematic pipeline in a very short amount of time. We had 12 hours of cinematics, and the rest, the one that I love the most is the last one, which was we had an AP team, and we had no overtime on that project. So to sum up all of that, we did identify the need to produce large amount of data in a very short amount of time. We reduced a lot of human errors. We had a lot of validation from Maya to Unreal to prevent people submitting things that they could have fixed very easily. We identified what we wanted from what type of structure we wanted to go for. We started with having our Nautilus script going into Unreal, then generate everything to ShotGrid. Then we use that data to generate content in Maya, and then everything was exported from Maya to Unreal. I think that is the end.